Okay, let's go to the question number 10. You have been told that 2 minus 3i is the root for this polynomial function. So the question is to find the remaining zeros for this p of x. So what we need to do is we have to remember conjugate theorem. Conjugate theorem says that if 2 minus 3i is the root for p, then its conjugate p is the conjugate of this 2 minus 3i, which actually is 2 plus 3i, is also the root for this polynomial. So if 2 plus 3i is also the root for, you see, this polynomial, what we need to do is we have two factors, right? X minus 2 minus 3i and x minus 2 plus 3i. So we can consider these two as factors for this polynomial. And even if these two are factors of this polynomial, so it's their product. The product is also a factor for this polynomial. So in order to determine the remaining factor, we need to do the following approach. Try to multiply these two and find the polynomial resulting. Then try to divide the polynomial p by the resulting polynomial. In such a way we can determine the coming quotients, and then using the quotient obtained we can determine the zero of the remaining zero for this polynomial. So clearly the product of this must be now obtained. So in order to obtain that, what we need to do is we have to consider the product of these two, x minus 2 minus 3i into x minus 2 plus 3i. So student, here x times x makes x squared. As you see, we obtained here x squared. And here x times this is going to be minus of 2 plus 3ix. And as you are multiplying again 2 minus 3i of x, you will get negative of 2 minus 3ix. And then finally, you see, when you operate these two, you will obtain that to be negative 4x. Because the negative of negative, which actually is positive 3i, will be cancelled by the negative of 3i. And what is remaining here is only minus 4x. And when you come to the last case, you see, that is to say x minus, when you just take the sum of the square of the modulus of these 2 minus 3i, you will obtain that to be 13. Because 2 times 2 is 4, and minus 3 times minus 3 makes what? Positive 9, and 4 plus 9 makes 13. So you will obtain the square of the radical 13, which actually is 13. Or you can directly multiply this with this. Look, 2 times 2 makes 4, and negative 3 times positive 3 makes minus 9, but due to I times I, which is being I squared negative 1, that term, the negative 9 turns to be positive 9, and 9 plus 4 makes 13. So you can have this one. Now look, as you are taking the product of these two, you obtain the quadratic expression, x squared minus 4x plus 13. So how are you going to obtain the next factor, or the remaining factor? To find the remaining factor, what we need to do is we need to divide this polynomial by this one, because we have obtained that 2 minus 3i and 2 plus 3i are the zeros for this p. So their product makes us to have this quadratic expression. So the remaining, the remaining expression can be obtained by dividing this p by x squared minus 4x plus 13. To do that, students, you need to apply long division technique. Just apply the one you studied in your high school, and then try to determine the remaining factor, and this can be obtained in the following way. Thus, students, as you are dividing p of x, which actually this one, by x squared minus 4x plus 13, you will come across with this value 2x plus 3. Okay, you can even know at the beginning here that 2x cubed divided by x squared is 2x times. And as you are performing this, you see, you will finally obtain the remainder of this to be 0 and the quotient to be 2x plus 3. Now, students, having 2x plus 3 by itself is enough to know the other 0 for this polynomial p, because the 0 of this is nothing but it is the 0 of these two. Thus, you can write now p as, look, p of x, the one we are having here, is the same as look, the product of these two expressions times 2x plus 3, because this basically is obtained from such division operation here. So from this you can understand that the roots or the zeros of this polynomial are, one is 2 minus 3i, because it is a zero of this one, as you see, and the zero for the second one is 2 plus 3i, so it can be considered as a zero of p2. And what is the zero of this one, students? Just bring this 3 to the right, minus 3, and divide both side by 2, so it's going to be minus 3 over 2. So minus 3 over 2 makes this 0. So the zeros of the factors are the zeros for, you see, the products. So 2 minus 3i, 2 plus 3i, and minus 3 over 2 are the zeros. Since 2 minus 3i is at the beginning given for you, the remaining zeros are the last two. 2 plus 3i and minus 3 over 2. So simple to understand, I think. Having this into account, what comes next is the next question, question number 11. In question number 11, you are asked to determine, you see, you are asked to determine the amplitude and the period for this particular function. Y of x equals minus 2 times sine of 3 over 2x. So how are you going to determine the amplitude and the period for this particular function? But before that, we need to know what amplitude and the period are. The amplitude of a function is nothing but it is the measure of, you see, the line segment from the x-axis up to the maximum value, or you may also take the measure of the line segment from the x-axis up to the minimum value, okay? So amplitude is distance measure, so it can't be negative, it must be always positive. And when you come to the period of this kind of function, the period of a function is nothing but it is an interval of length where the functional value is going to be repeated. Whenever the functional value is repeated, it is repeating itself within a certain small interval, the first small positive interval is going to be the period for the function given. So whenever you are given such kind of function, students, there is one thing that I would like to point out here. The amplitude and the period for any sort of function which is given by y is equal to a times sine bx plus c is given by, the amplitude is given by absolute value of a, and the period is given by 2 pi divided by absolute value of b. So both amplitude and the period of such kind of function can be determined by using absolute value of a and 2 pi over absolute value of b, right? So the absolute value of a is taken because amplitude must be of positive value because it's a distance measure. And here absolute value of b must be again, you see, positive because we are just considering the length of the interval, you see, so we need to have a positive output. So even if you do have also, you see, cosine expression, this is happening the same. The amplitude and the period of y equals a cos bx plus c are absolute value of a and 2 pi over absolute value of b respectively. So even though you are having, you see, a sine expression or a cosine expression of this kind, nothing is changed concerning to the amplitude and the period of the expressions, okay? You simply take absolute value of a and 2 pi over absolute value of b respectively. So here the phase shift in both cases is minus c over b. What makes the expression inside the bracket 0 is nothing but it is a phase shift, and it's going to be minus c over what? B. The phase shift is nothing but it represents the extent or the shift of the zero of the what student? I mean the what can I say? The extent at which the origin has shifted. You see, either to the right or to the left from you see the y-x intersection. Okay, from x and y intersection or from the origin. And that shift is determined by minus c over b, which actually is the zero of this one, right? bx plus c is 0 at minus c over b. The same is true in the case of these two. So everything is simple now, a matter of plugging the given expressions. So in the case of, you see, our question, in the case of our question, you are given that y is minus 2 times sine 3 over 2x. So obviously a is here minus 2. So we need to take the absolute value of minus 2. So that is obtained to be 2. So the amplitude, the maximum distance of, you see the maximum distance that we have from, you see, points on this function from the x-axis is going to be 2. And the interval, I mean the period for this particular function is going to be determined by 2 pi over, you see, absolute value of b. And we knew that b is 3 over 2 because the coefficient of x is treated to be our b value. So b is 3 over 2. So when you simplify 2 pi by 3 over 2, you will obtain that to be 4 pi over 3. So within 4 pi over 3 interval, everything is repeating itself. That is what's meant by saying the period. So the period is 4 pi over 3 and the amplitude is 2, as you see. If you were asked to determine the phase shift, your C value is 0. So 0 divided by 3 over 2 is going to be what? 0. That is to say that, you see, everything will be drawn. We don't have any sort of shift. Everything is going to pass through the origin in the case of this, okay? So this is the idea.